Hey, all Brad here with another quick video. Today on the bench, I've got an IO slash widget board that my customer Dan sent in. It's from his Robotron. He said occasionally the move left input would stick. It would stay on even though he wasn't actuating the joystick. And my first thought was, check the Wicco joystick leaf switch, try cleaning the contact, running some paper through it with a little friction, that sort of stuff. He said, hey, I actually changed the joystick out and it just randomly does it intermittently. So I said, just send the IO board in, we'll go through it. So on this video, I'm going to show you how I troubleshoot uh, these types of issues and the things we look for on it. So let me switch over right now to show you on the bench. So here's the IO board on the bench, and just to kind of do a brief overview on these guys, here's another one. Um, Power, all the data, address bus, everything comes through this 20-pin ribbon cable comes in, and then there's a 6821 PIA on the board, a peripheral interface adapter. And what this does is allow the microprocessor, the 6809, on the MPU to extend its I/O capability pretty much. So it communicates to this with a few lines. It's addressable, and then with that you get multiple ports or banks of I/O on here. So uh, on most of the Williams games, these are used pretty much exclusively for inputs, but they could be configured for outputs as well. And they did that on a few games that they had licensed out. Lotto, Fun, they actually drive some lights and stuff like that with the same board with a few modifications. And then from the inputs, from the joysticks and buttons and things, these come in and get buffered through some 4049, I think, inverters here. So um, it kind of isolates the PIA and the rest of the circuitry from what's happening at the control panel. So you've got three of those. And then these are basically muxers, these 257s. And I'll show you on the schematic how they work. Um, and then there's a filter cap on here for the 5 volts. And then you have these two 10-pin Molex headers that come in for the I/O. The original ones had round pins. These ones I've replaced with the square pin. And we'll go over that. So um, here's the drawing from the schematic that I'm sharing now. So here's a layout of the board that you were just seeing. Let me get over to that. Click on this. So uh, location of the different ICs on the board, and then we'll jump right into the schematic here. So this is for Robotron. So you'll see here that the move left comes in over here on 3J3-3. And there's a 1K current limiting resistor in series, kind of attenuates the signal and prevents any major current flows. That's kind of like best practice when it comes to bringing in I/O in. And then you'll see this black dot here, that's a connection point, and that goes up to this SIP network resistor, which has 5 volts where this little triangle is. It's connected to the plus 5, and then it goes through an array of 4.7 K resistors. And what this is known as is a pull-up resistor. So 5 volts goes through, comes down through this connection 8. And so if nothing is connected to your input over here, in other words, that leaf switch on the Wicco or your button is open, this pulls that signal high up to 5 volts. So here's the input to that buffer we were talking about, that inverting buffer 4049, which is IC6. So it comes in on pin 3, and if there's nothing actuated, again, that's going to be sitting at 5 volts, and then therefore your output, this little circle on the output indicates it's inverting, on pin 2 is going to be low or ground all the time. So as you press the button and connect that pin to ground, it'll override that 4.7K and pull this low, which will then send the output high. And then after it comes out of this stage, it goes in this 257 kind of muxer here. And what this does, the output side of this chip has 4 outputs and 8 inputs. So you'll see here there's 2 banks basically. So you have A1, 2, 3, and 4, or A0, 1, 2, 3, and then the same on the bank B. So you have B, 1, 2, 3, 4. And there's an S here which controls which bank is being passed as an input to the output. And basically, if this is high, bank A goes, and if it's low, bank B goes. So what they do is the PIA controls and toggles this S pin on pin 1 and switches between these 4 input banks to drive the output into the PIA. And he keeps track of which is which. And that's how you're able to get 16 inputs on that card while only using 8 pins on the PIA. It just toggles between the two. So in terms of troubleshooting, the things I want to look for, obviously I want to make sure that the pin is getting to R8 here for the move left. I want to measure the resistance on R8, make sure it's 1K, it's not open. Then I want to come down and verify between 5 volts, and I can do this all with the power off, with 5 volts and um, the input on pin 3, that I should see 4.7K ohms between those 2 points on the board. That ensures that where the 5 volts coming in, it's running through that pull-up resistor. And if all that's good, then what I can do is power it up and ground uh, pin 3 here on the I/O. And with that, I should see pin 2 toggle and change state. And a lot of times these buffers do fail because they're CMOS, which are more sensitive than a traditional bipolar TTL. And then at that point, I can make sure that it's passing through, seeing that state change through this multiplexer here, this 257. And if all that checks good, typically, it may be a PIA. You want to check continuity and make sure nothing else is shorted. But they're pretty straightforward to troubleshoot. I mean, usually within minutes of having an input, we can get to the root cause. And then with intermittent problems, are always more difficult. The first challenge is to try to reproduce this intermittent condition. And for that, I will jump over to some gameplay screen. So what I have loaded up here is Splat. And the reason I use Splat is because it's the only game that uses this I/O board. Keep in mind, Stargate used this, Joust, Robotron, Bubbles, and Splat use the same I/O board. And Splat is the only one that uses all 16 of the inputs. So for testing purposes, when I work on one of these, I use Splat so I can test all 16 inputs. So if the customer ends up moving it from Stargate to Joust or Robotron, I know all the inputs are going to work fine. In the past, when I first did this, if it was Robotron, I only tested those inputs, and then if someone moved it, I do a lot of work for guys with arcades, so they're moving components around, or they keep a spare I/O board on the shelf, and then maybe they use it in a Joust, maybe they use it in a Robotron. So by testing on Splat with all 16 inputs, I know for I'm very solid that all 16 are going to work as expected. So what I'm going to do here is jump into the diagnostic screen. I've got a PlayStation controller here where I can go in and out. So here we are on the switch test. So again, some of these come from the ROM board inputs for the diagnostic switches and coin slam switch on the coin door, and then the rest of them the 16 come through this I/O board. And I'm running this controller through basically an Arduino, and I wrote some code where I can press one button on here and test all 16 inputs. So I'm going to go ahead and press the X button, and you should see all 16 of the inputs sequentially. I have a short delay between them. And then we can go through and count them. But from the very first where it says walk up 1 all the way down to throw right 2, there's going to be 16 there. And usually if there's a problem with the board, you'll see one missing, or as soon as you come into the screen, one will be lit. So I'm going to clear them. And what I'm going to do now is switch over, leave that gameplay up, and I'm going to switch to where you can see the board down here. And what I'm going to do is wiggle this this ribbon cable here, right here, my finger. You probably see it in the frame. I'm going to wiggle this. And actually, let me switch over so I can see the gameplay screen in real time here. So you can see as I'm wiggling this cable, whoop, there, I've got 2 inputs stuck on. So clearly, the problem here is the ribbon cable, right? Which is when I work on any Williams boards, the I/O boards or ROM board, they get new capacitor, filter cap, they get new ribbon cables, they get new Molex headers with the square pins. That's like before I even power them up or put them on the bench. The cost and the effort to change those for me is pretty low. So, oh, I just got the whole thing to light up there. So again, I'm just moving this around, manipulating a little bit, which to be honest, I'm kind of lucky that happened. But let's go back to the uh, schematic. Let me switch over. Might lose that one. Hang on one moment here. There we go. And I'll switch to that again. So let me do an F11 here. I'll do full screen. So you can see here that that input for the move left comes into IC6, which is the buffer. 99% certain the issue is on the ribbon cable, but just for safeguard, these 4049 buffers here are under $1 a piece, and they take me probably 5 minutes to swap one out. So move left, the one the customer was complaining of, is on IC6. And if we go up to the layout here, you can see IC6 is in the center of the board. So I'm going to change out C8, which is the electrolytic filter cap. I'm going to change out the 20-pin ribbon cable I make these myself with the brand new 3M parts. I have the press for them. I'm going to change out the two 10-pin Molex headers. And again, this 4049 and IC6, just to be safe for the cost and the effort. That way, when I get it back, there's no question that this customer will not have problem with that left move sticking again. So with that, I'm going to wrap up this video. I want to thank everybody for watching, and hopefully I'll have more to come in the future here shortly. I've got quite a bit more work coming in. I've been trying to work on some of my own games. I got Turkey Shoot in progress. I just got a T2 game. I've got to go through the monitor and do a few other things. So stay tuned for that. Thanks for watching. Bye-bye.